the sum of these particular rankings, which is 12 plus 24, okay, times n cubed minus n again, which is 10 cubed minus 10, okay, plus the product of the rankings, which is 12 times 24. Okay, so they're just numbers, yeah, it's just subtractions and a bit of division and some exponentiation. So let's not get too worried about this. So let's do this in parts. So Rs is equal to, let's see what this factor is here. It's 10 cubed. Okay, gives us 1000 minus 10 gives us 990. So it's 990 minus 6 times 33. So 6 times 33 is 198. So minus 198. Okay, and in this case here we have 36. We have 36 divided by 2 gives us 18. So it's going to be minus 18, and that needs to be divided by once again 10 cubed minus 10 is 990. Okay, minus we have 24. We have 36 here. Okay, times 10 cubed minus 10 is 990. Okay, and plus in this case here we have 12 times 24 gives us a value of 288 plus 288, and this is going to be our correlation coefficient. So what do we get? We get R of S is equal to, we have 990 minus 198 minus 18 gives us a numerator of 774, which needs to be divided by, on the bottom here we have 990 minus, okay, excuse me, minus 46 times 990, okay, plus 288, okay, gives us a value of minus 34,362. Okay, and then when we do our division, so we have 774 divided by 34362, negative it's going to be, and that gives us a 0.02 value of a correlation coefficient. I'm hoping that I haven't made any errors here in these calculations. I think everything is good from a formulaic perspective. I don't think that there's any major problems here. Let me just make sure, just to double sanity check this here. Oh, sorry, I have made a small mistake, and the mistake is actually in our formula. There should have been a square root here. No wonder. Okay, that's a square root. So really, what we need to do is we need to be calculating a square root here, which actually doesn't make sense because we have a negative value coming through. So let's just see here. I have made this should be squared. Yeah, so there's a small little mistake here. Okay, so let's just be careful with the formula. I suppose I have to rewrite the formula. So actually this needs to be squared. I'm just going to ignore this bit here. Okay, and it's also the square root of this needs to be thrown in here. Getting a little bit carried away here with myself. Yeah. Okay, so the formula is Rs is n cubed minus n, okay, minus 6 times the sum of the d squareds, minus t of x plus t of y divided by 2, divided by the square root of this factor here, which is n cubed minus n squared, minus the sum of the tx's plus the ty's times n cubed minus n, plus the product of them, and it's the square root of it. So in this case here we have Rs is equal to 774, okay, and we have 990 to be squared, okay, minus 36 times 990, okay, plus 288 gives us a value of, it's the square root of 944748. So we get the square root of 944748, which gives us a value of 971. So this is 774 divided by 971 let's say 0.98, gives us an RS value in this case is equal to 774 divided by 971.98 gives us a value of 0.796, okay, to 3 decimal places, okay? And that's our correlation coefficient. And actually this is strange, not that it's strange, but this is a little bit different to the correlation coefficient that we had earlier on, okay, when we did the calculation without using this particular formula here, okay, the proper formula. Let me just rewrite that formula down a little bit clearer so that we're under no illusions in relation to what that formula actually looks like, and I'll write it a bit bigger here. It's the RS is equal to the number of paired observations cubed minus the number of paired observations minus 6 times the sum of the ranks, the differences in the ranks squared, yeah, minus the t of x value plus the t of y value, okay, divided by 2, and that needs to be divided by, it's a square root, okay, and it's the square root of n cubed minus n to be squared minus t of x plus t of y, okay, times n cubed minus n plus t of x times t of y, and that's the formula, okay, to take into consideration of TIAs. Okay, that's important to take this into consideration when we're doing our calculation. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. And thanks for watching. Okay, bye bye.